So, morning guys, good morning. So, I welcome you guys to NEET World Institute. So, in this session, we are going to concentrate on the EAPCET physics. This is particularly EAPCET series program, right, for medical as well as engineering students. So, we have covered the topic like units and dimensions, measurements and errors, and motion in a straight line, and the current topic is motion in a plane, right? And today we will do the remaining topic and solve the PYQs of the EAPCET questions. Okay, so let us wait for 1 or 2 minutes. The people are joining here. Okay, yes. Yeah, last 30 seconds, we'll see. Okay, we'll start the class because people are joining now. Okay, let's start the class. So, let us discuss what we have seen in the last class. Okay, so the topic is relative motion, right? Relative motion. So, we have discussed the formula for the relative motion, and we have started the topic, the river and the man, or river or the boat, right now. So, this was the topic we have started. So, let us see that what are the things we have there in that river and man problem. Okay. So, main thing first you need to understand is velocity of the river with respect to ground, which is nothing but, let me write VRG, nothing but velocity of river with respect to ground. Next one, velocity of man with respect to ground. Velocity of man with respect to ground. Next is velocity of a river with respect to man. Okay, or velocity of a man with respect to river also we can take. Okay, anything. So, velocity of a man with respect to river is nothing but velocity VMR, man with respect to river. Okay. So, this is the terms which we are going to use. Okay, and before that we need to know how the terms we are going to use in that. Okay, two conditions. Like first topic is river man problem. So under this, first one what we are going to see is shortest distance. Second one is shortest time taken. Two things right now. So shortest distance we have discussed in the last class. So now we will discuss what is the shortest time. Okay, shortest time. So we know the condition, na? Like if this is my river flowing, no? So river flowing in this direction, if I start like this from point A to point B, if I keep starting, no, I will reach in point C, right? So this is my velocity of a river with respect to ground, velocity of a man with respect to river, velocity of a man with respect to ground, right? Another condition is if I start from point A to point B, I will end up at point C. So this is my velocity of a man with respect to river, velocity of a man with respect to ground, and velocity of the river with respect to ground. So this is the velocity, river direction. Okay. So two conditions, two possibilities I can have. Okay. So the possibilities for the first one is, if I start like this, no, with the flow of water, I am going to point C, which means I can reach easily the other end. I can reach easily, okay, but it will take longest time, longest distance, no, but the shortest distance is this one. The longest distance is this one, okay, but the longest distance for this one, no, like it will take shortest time because I am going along with the river. I am going along with the river. So if I go along with the river, no, I can reach easily, right? So this is my diagram for time, that is shortest time, and this is my diagram for distance, that is shortest distance. Okay. So two possibilities. First possibility we have seen, and let me write that also. If this is angle theta and if this is angle alpha, let me take, okay, alpha, angle theta and angle alpha, right now. So for shortest distance, let me write shortest distance in the sense sin theta cos theta tan theta. Shortest time in the sense sin alpha cos alpha tan alpha. Okay. So alpha. Okay. So first we will write the alphas. Okay. Opposite by hypotenuse. Velocity of a river with respect to ground divided by velocity of a man with respect to ground. Next one, adjacent by hypotenuse. Velocity of a man with respect to river by velocity of a man with respect to ground. Next is tan, opposite by adjacent. Velocity of a river with respect to ground divided by velocity of a man with respect to river. So this is my trigonometric ratios for the shortest time taken. Okay, now shortest distance, sin theta, opposite, velocity of a river with respect to ground by velocity of a man with respect to river, Next, velocity of a man with respect to ground by velocity of a man with respect to river. Next one is velocity of a river with respect to ground by velocity of man with respect to ground. So if you notice here, no, like the ratios are different, right? Sin alpha, no, like alphas I have used for shortest time, theta I have used for shortest distance. Okay. Sin alpha, velocity of a river with respect to ground. See, one more thing, I can write like this also. Velocity of a river with respect to ground is nothing but velocity of a river minus velocity of a ground. What is velocity of a ground? It is 0. right now it is 0. Ground is not moving, no. So I can say that velocity of a river also, okay, velocity of a river also. So now come to the point. So velocity of a river with respect to ground by velocity of a man with respect to ground, whereas sin theta is nothing but, it is sin alpha, okay, sin theta is nothing but velocity of a river with respect to ground, okay, fine. But when you see the denominator, velocity of a man with respect to river, like the ratios are changing here, no, because I am using the shortest path to travel the shortest term. I have taken the shortest path initially, so that I will reach the shortest time. I have taken the longest path, so I will reach the shortest distance, right. See, if I start here, I need to end up here, but instead of here I have ended here because of the river flowing direction. Now I have started here, I need to end here, but because of the river flowing direction I have ended in the straight. So if I see here, I have ended like this, no, let me draw this. I have ended like this, I have ended like this. So if you see here, this one will take shortest time to reach the other end, this one will take shortest distance, okay, that's why I have written time and distance, okay. You can take a note of this so that it will be easy for you guys to solve the problems, okay. Done. Completed? Yes. Fast. Okay, can we see some problems for this now? Okay, before that I will teach you one more topic, that is rain and a man problem, okay, rain and man problem. Fine, completed now. Can we go for the next one? Yes. So this is river man, next is rain man, okay. So next one is rain man problem, okay. So in this, what are the terms we are using now? Velocity of a rain, velocity of a man, velocity of rain, velocity of man, okay. So next one is velocity of a rain with respect to man, or velocity of man with respect to rain, that's the thing, that one we know, okay. See, so rain, obviously vertical direction we'll assume, okay, now, and the man is walking like this in this direction, okay. So can I write the vector like this? Draw the vector. This is my velocity of a rain and this is my velocity of a man, right. So if I want to write velocity of a rain with respect to man is nothing but velocity of a rain minus velocity of a man. So this is the vector things, no, everything are vector only, no. When I redraw the diagram, can I draw like this? Velocity of rain, okay, fine. Velocity of a man is there, no, see here, velocity of a rain plus minus velocity of a man. So in negative direction. So man is walking like this, okay, original direction, but this is my velocity of a man, yeah, position. I mean, to find the velocity, I mean, to which direction I need to hold the umbrella, okay. So this is my, yes, yeah, this is the thing where I can hold the umbrella, right now. So first vector, second vector, and the resultant vector will not be like this, because if I draw the resultant vector in this direction, no, it won't be a resultant vector, right. So I need to draw the resultant vector towards, yeah, starting this point, like starting at the tail and ending at the head point, okay. This is my umbrella position. I need to hold the umbrella like this, okay. So this is a glance of the rain and man problem. Take a note of this. We'll go for the next one. Done? Can we see problem now? Okay, let's start doing the problems. Fine. So first question, let me read that question, okay. So a train 100-meter long, traveling 100-meter long train, okay. Traveling at 40 meter per second overtakes another train, okay, 200-meter long. So this is going with 40 meter per second and another train is going with 30 meter per second, which is 200 meter long they have given, 200 meter long, okay. The time taken by the first train to pass the second train is, right. So when I talk about this diagram, velocities both are in the same direction. This is A train and this is B train, okay. So velocity of A will be equals to 40 meter per second, velocity of B is equals to 30 meter per second. Okay, so when I talk about this one, no, this front position is coming here. Let me assume is coming in the sense this one need to cover 200 meter. Like this train need to cover 200 meter to come here exactly. Again 100 meter to take over the train. Like it should be like this, no. Then only it has been taken over. Yes, na? It has been taken over. So this is the A, which means it should cover 300 meter. A should cover 300 meter. Okay. Now velocity both are in the same direction, positive direction. Velocity of A with respect to B is nothing but velocity of A minus velocity of B. So, velocity of A is 40 minus velocity of B is 30, which is nothing but 10 meter per second. So, we know the velocities now, velocity we know. Now, what is the thing they are asking? Time, they are asking time. So, we know that velocity is equals to displacement by time, where time is nothing but displacement by velocity. What is displacement of 300 meter? It has been taken 300 divided by what is the velocity? 10. So, answer will be 30 seconds. This is the answer. So, this is how you will solve the question when they are given in the relative motion. Okay, when they are given in the relative motion. Fine, you can take a note of this. Done? Okay. The next question. Yes, let me dictate the question. A 150 meter long train is moving to north at a speed of 10 meter per second. 150 meter long train. Okay. So, with the speed of 10 meter per second. So, with the speed of 10 meter per second. So, 10 meter per second in the north direction. Now, a parrot flying towards south with a speed of 5 meter per second. So, this is the parrot. Let me write, see, this is the parrot towards south 5 meter per second. Okay. Then, the time taken by the parrot to cross the train, the time taken by the parrot to cross the train is, right? Yes, I guess the camera is fine now, right? Okay. So, now what we can understand from here? See, train is obviously too much big, guys. Yes, no, it's too much like lengthy. When you talk about a parrot, it's like a point. It's like a point only, for the train. Yes, no, it's like a point. It's just a point. I can negligible the length of the parrot, right? So, how much distance it will cover to cross 150 meter? Fine, that's good. You have told 150 meter, the displacement will be 150 meter. What about the velocity? Here is the thing. One velocity is going towards down, one velocity is going up. So, this one will be positive, this one will be negative. So, velocity of a parrot now 5 meter per second, this is 10 meter per second. So, velocity of a train with respect to parrot will be nothing but, so velocity of a train minus velocity of a parrot. So, velocity of a parrot is minus 5. So, velocity of a train is 10. So, 10 minus of minus 5 is nothing but 15 meter per second. Now, velocity is nothing but displacement by time, where time is nothing but displacement by velocity. What is displacement? 150. What is time? Sorry, velocity 15. Displacement 150, velocity 15, which is nothing but 10 seconds for the parrot to complete the 150-meter long train, or to take over the 150-meter long train. So this is the answer for the given question. Okay. Done? Fine. Next question we will see. Okay, good. So the next question is, the velocity of A and B are, the velocity of A and B are, they have given the question, velocity of A and B are, velocity of A, velocity of B. How much is 2i plus 4j, that is 2i cap plus 4j cap, and velocity of B is nothing but 3i minus 7j, 3i minus 7j. So this is my question, what is the thing they have given? No, here need to find velocity of A with respect to B and velocity of B with respect to A. The both things I need to find. Okay. So first, velocity of A with respect to B is nothing but velocity of A minus velocity of B. What is velocity of A? Yes, 2i cap plus 4j cap minus of 3i cap minus 7j cap. So 2i cap plus 4j cap minus 3i cap minus of minus plus 7j cap, which is nothing but minus I cap plus 11j cap is the velocity of A with respect to B. Okay. Now second one, velocity of B with respect to A is given as velocity of B minus velocity of A. So which is nothing but velocity of B is 3i cap minus 7j cap minus of 2i cap plus 4j cap, right. So 3i cap minus 7j cap minus 2i cap minus 4j cap, so which is nothing but I cap minus 11j cap. Here what it is? Minus I cap plus 11j cap, but here I cap minus 11j cap. When I talk about the magnitude of the velocities, no, for these two cases it will be same, because both the magnitudes, no, root over 1 square plus 11 square only will come. Okay. So this is the answer for the given question, right. Take a note of this, and I will give a next question based on the acceleration. Okay. Done. Good. So the next question. So acceleration of A is nothing but 3 I cap minus 7 J cap plus 5 K cap. Acceleration of B minus 11 I cap minus 13 J cap plus 15 K cap. Okay, this is my acceleration of A and B. Need to find acceleration of A with respect to B and acceleration of B with respect to A. Both I need to get it. So get it fast. Yeah, I need the answer for this given questions now. Fast. So whoever watching in online, no, you can give answer in the comment boxes, so we can check the answers. Okay. Fast. Last 30 seconds. Okay, we'll see the answer now. So first one, velocity, so acceleration of A with respect to B is nothing but acceleration of A minus acceleration of B. So what is acceleration of A? 3I minus 7J plus 5K. 3I minus 7J plus 5K minus, what is acceleration of B? Minus 11I minus 13J plus 15K. Minus 11I minus 13J plus 15K. Now I can solve it, right? So 3I minus 7J plus 5K, minus of minus plus 11I, minus of minus plus 13J, and then minus of plus will be minus 15K. So 3I plus 11I. So will be 14I cap minus 7J plus 13J. How much? 6, no? So plus 6J, 5 and minus. So minus 10K, right? Right, no? This is my answer for the question. Next one, well, acceleration of B with respect to A is nothing but acceleration of B minus acceleration of A. So acceleration of B is minus 11I minus 13J plus 15K. Minus 11I minus 13J plus 15K minus 3I minus 7J 5K. 3I minus 7J plus 5K. So minus 11I minus 13J plus 15K minus 3I will come, minus of minus plus 7J will come, minus of plus will be minus 5K. Now I can solve it. Last step, minus and this minus 14, no? So minus 14I minus and this plus, so minus 6J, and this plus and this minus, so plus 10K. So if you see here, only the sign changes here, plus minus plus. 14I cap, 6J cap minus 10K cap, minus 14I cap minus 6J cap plus 10K cap. Okay, so this is the answer. Can we go for the next question now? Yes. Okay. So next is the PYQ question. Okay. Now, yeah, everything like step by step we are solving, like the basic level, next the now moderate level and the PYQs. Okay. Now the PYQs will solve. So a swimmer crosses a river. A swimmer crosses a river, which means a man crosses a river. Wait a minute. Yes. A man crosses a river in a shortest distance. Shortest distance means which is the diagram I should use? The diagram I need to take this one. So shortest distance diagram theta. Okay, shortest distance diagram theta. Velocity of swimmer with respect to river. Velocity of swimmer with respect to ground. Velocity of a river with respect to ground. Okay. Now, if the swimmer try to swim 4 kilometer per hour, maintaining 120 degree. So, he is maintaining 120 degree. Total angle they have given. Total angle is 120 degree. Right? Maintaining in the sense with water only. So, how much? 4 kilometer per hour. 4 kilometer per hour. Then, with the downstream, down the stream. So, this is the downstream, okay? Because down the stream only, obviously the person will go in this direction, right now? So, this is the direction of the river. So, then the speed of the river they are asking. What is the speed of the river? Need to find the speed of the river. Wait a minute, the camera, I will adjust it. Sorry for the disturbance, I guess the camera is clear now. Fine. Right now? So, let me write the trigonometric ratios. Sin theta will be equals to opposite by hypotenuse. Na? Velocity of a river with respect to ground divided by velocity of a swimmer with respect to river. Before that, I need to find what is theta. If this is 90, this one will be, yes, theta will be 30 degree. Total angle is 120, but if I talk about only theta, it is 30 degree. Okay. Cos theta will be equals to velocity of adjacent, no, velocity of swimmer with respect to river divided by velocity of a swimmer with respect to ground. Sorry, it's ulta. Velocity of a swimmer with respect to ground by velocity of a swimmer with respect to river. Then tan theta, velocity of river with respect to ground by velocity of swimmer with respect to ground. Okay. Now the thing is I need to find this one, velocity of a river with respect to ground. Where I can you see velocity of a river with respect to ground, I can use here this one, sin theta I can use, right now, sin theta I can use, cos theta I can't use, and the tan theta also I can use. Any two trigonometric ratios I can use. Now the unknowns are there, no, the things is there like variable, velocity of a river with respect to ground, velocity of a river with respect to ground. But when I notice this one, swimmer with respect to ground I don't know the value, but swimmer with respect to river I know the value, right? So I can use this. Sin theta no, sin 30 will be equals to velocity of a river with respect to ground, velocity of a swimmer with respect to ground is 4. Sin 30 is 1 by 2. 1 by 2 into 4 will be equals to velocity of a river with respect to ground. So velocity of a river with respect to ground will be equals to 1 times and this 2 times, 2 kilometer per hour. This is the answer. As simple as is easy, no? When you try to understand the application point, it will be easy to solve the questions. Okay? Yeah, you can take it. Done? Okay. So next question, A swimmer reaches the other bank of the flowing river exactly opposite to the starting point. Exactly opposite to the starting point, like in the sense, this is the bank where the person is standing, no, other bank means this one. So exactly if we start here, you need to reach here itself. So that what you need to do, you need to start from some angle, right, so that you can reach here. So this is B and this is C and this is A, right. Now come to the question. If he was swimming at 2 km per hour while maintaining 150 degree, how much? 2 km per hour. Then with the flow, this is the flow, okay. Then time taken by him to cross the river 1 km wide. Time taken by him to cross the river 1 km wide. So how much? This is 1 km wide, okay. Width wide, let me take. So 1 km. How much time he has been taken? So for that, what I need to get? I need to get the velocity of this AC point, na? Yes. So this is my velocity of a swimmer with respect to river, velocity of a swimmer with respect to ground, velocity of a river with respect to ground. Right? No? Let me write theta. This is theta, okay. Theta will be equals to 60 degree. 60 degree. If this is 90 degree, remaining angle will be 150 minus 90 is 60. Okay. I have written the theta also here. Right. So sin theta will be equals to, I need this velocity. Okay. Sin theta will be equals to velocity of a river with respect to ground by velocity of a swimmer with respect to river. Next, cos theta, velocity of a swimmer with respect to ground by velocity of a swimmer with respect to river. Next is tan theta, velocity of a river with respect to ground by velocity of swimmer with respect to ground. So I need to find velocity of swimmer with respect to ground. No, sin theta I can't use it. Cos theta, yes, is there, the variable is there, okay, fine. And the tan theta also, the variable is there, okay, fine. Two things, I got it. Now if you see, is there any other thing? Cos tan value I know, cos 60, tan 60 I know, right? Velocity of a swimmer with respect to ground I need to get it. But one more thing, velocity of a swimmer with respect to river, is the value is given? Yes, it's given. So I can use cos theta now. What about tan theta? River with respect to ground, I don't know the value, right? I need to get the value, and again I need to take the Pythagoras theorem. I can use this also. Tan 60 value I know, swimmer with respect to ground I don't know, and this also I don't know. Yeah, I can't use this one. Right? So cos 60 will be equals to velocity of a swimmer with respect to ground by velocity of a swimmer with respect to river is 2. Cos 60 is 1 by 2 into 2 will be equals to velocity of a swimmer with respect to ground. So 2 and 2 will get cancelled. So velocity of a swimmer with respect to ground is 1 km per hour. So with that we can't stop. They are asking what is the time taken? Time taken to cross the river exactly opposite point, not shortest time, exactly opposite point, how much time taken, right? So for that I need the velocity, this only, like this straight velocity. Now I got that velocity. Velocity of a swimmer with respect to ground will be equals to 1 km per hour, and river width is nothing but 1 km. The time I need to get it. So velocity is equals to displacement by time, where time will be equals to displacement by velocity. What is the displacement? 1 km. What is time? Sir, what is velocity? 1 km per hour. Width is 1 km. 1 kilometer by 1 kilometer per hour, which is nothing but 1 hour. So this is the time taken to cross exactly opposite bank of the river, opposite bank of the river. So this is my answer. This is how you need to solve the questions when they are asking in the relative motion, that too in river and man problem. Got it? Okay. So can we go for the next one? Next problem we'll see. So the next problem is the speed of a boat is 5 km per hour in still water. Speed of a boat 5 km per hour in still water, which means velocity of a boat with respect to river is nothing but 5 km per hour. Understood? Yes. So it crosses the river width 1 km along the shortest possible path in 15 minutes. So along the shortest possible path, so which means this is my diagram. Theta, velocity of boat with respect to river, velocity of boat with respect to ground, velocity of river with respect to ground. How much they are given? Like the width is 1 km. The width is 1 km, right? And in 15 minutes, this one they have crossed in 15 minutes. Time taken 15 minutes, which is nothing but 0.25 hours in hours, like everything given in hours, no? So 1/4, no? Yes. So the velocity of a river, velocity of the river they are asking, velocity of the river is, the velocity of the river is, okay. So I can find easily, no, this one. Okay. 1 km, 15 minutes. So I can use velocity equals to displacement by time first. Velocity of a boat with respect to ground is equals to displacement, like the width of the river divided by time taken, which is nothing but 1 km divided by 1 km divided by 1 by 0.25, which will be equals to 100 multiplied by 100 divide by 100 also, okay, divide by 25. 1 times and this is 4 times. This is 4 km per hour. 4 km per hour, 5 km per hour, this one. Obviously, this one will be 3 km per hour. 3, 4, 5 triangle, no? Yes. I can find here easily. So, velocity of the river with respect to ground whole square plus velocity of a boat with respect to ground whole square will be equals to velocity of a boat with respect to river whole square, because I am using the Pythagoras theorem. A square plus b square will be equals to c square, right? What is velocity of a river with respect to ground? I need to find this one. I will keep as it is. Will be equals to velocity of a boat with respect to river square minus velocity of a boat with respect to ground square. What is velocity of a boat with respect to river? 5. 5 square minus this is 4 square will be nothing but 25 minus 16. This is 9. So velocity of a river with respect to ground will be equals to under root of 9, which is equals to 3 km per hour. This is the answer. That's it. So this is the answer for the given question when the distance, I mean the width of the river has been given and time has been given. So need to find the unknown here. So for that we have used the velocity formula, that is displacement by time, and I got the velocity for boat with respect to ground, and we know the velocity of boat with respect to river, and we got the value of velocity of river with respect to ground. Okay. So I guess it's clear now, right? So with this we'll end the session. Okay, with this we'll end the session. So I hope you got idea about how to solve the questions, right? Okay guys, thank you. We'll meet in the next class.